You really should be able to prove all of the formulae that you use in the A-level, but these two in particular, it's good to be able to explain to the examiner that you know what's going on and you could be asked to prove it. So let's look at Newton-Raphson first. What's the idea? We get the tangent line and then we find out where the tangent line crosses the x-axis. Okay, so let's do that properly using actual maths. This is the curve y equals f of x. And what do we need for the equation of a tangent? Well, we need a point on the line and the gradient of the line. Right, there's a point on the line. X naught, well, its y coordinate will be what we get when we put x naught into the function. F of x naught. That would be what we would get if we put x naught into y equals. That'd be the y coordinate. What about the gradient? How would we get the gradient? Well, we would differentiate the function and then we would sub in the point that we're interested in. I mean, I'm writing the same thing twice really, but f prime is the gradient function and then evaluate it at x naught. So what is the gradient here? Evaluated, that's better. It looks like evaluated at x is x naught. Right, now let's build the equation of the tangent. So the equation of any line, you probably write that the other way around, but I prefer it that way. There's the gradient. And here's the point on the line, which in our case is x naught, f of x naught. Okay, what are we doing with that tangent? We're finding out where it crosses the x-axis, so we're going to put y as 0. There's y, that's going to be 0. Notice, by the way, how I'm using different sizes of brackets so they don't get mixed up. So this bracket I'm doing really big, that bracket I'm doing smaller. That's a standard mathematician trick, is to use different shape brackets and different size brackets to control the algebra. Right, divide that under there. It's a show that, so go nice and slowly. And then move this guy over. And that is x1. That is where the tangent crosses the x-axis. In general, obviously, this 0 would be an n, and this then would be n plus 1 down there. So if this is any point in the sequence of Newton-Raphson that we're doing, in fact, maybe I should call it xn. So this would be xn. Doesn't need to be the first one, does it? It's any of them. So this would be xn, n, xn. Luckily, you watched the video and then write notes like I told you. That's xn, and then this is xn, and this is xn plus 1. The next one in the iterative sequence comes from that. Right, trapezium rule. We're going to split this up and we're going to use the area of a trapezium. So if that's A and that's B and they're the parallel bits and the difference between them is h, then the formula that we're using is a half h and then the sum of the parallel sides, A plus B. I will split this up into 4 for the purpose of this demonstration, explanation, proof thing. I'm going to make 4 trapezia, like that. x1, x2, x3, x4, x5. 5 ordinates, 4 intervals. This height here from there to there will be what happens when I put this into the function. And then if I put x2 into the function, if I put x3 in, I get y3. So these are all the other ordinates. The y ordinates is those heights. So I've got trapezium number 1. Should I call them 1, 2, 3, 4? Yeah. I've got 4 trapezia and I'm going to find the area of each one and then add them up. So the area will be this trapezia, which is the 2 parallel sides times half the distance between them. I don't know why I wrote it like that. And I'm going to use h for the distance between them, and it's all equally spaced, uniformly spaced out. So this is h, this is h, this is h, this is h. Okay, that's number 1 trapezia. Then we've got number 2 trapezia, number 3 trapezia, and number 4 trapezia. I'm going to get all of those areas and add them up. So this one, half h, that's the distance between, and then the sum of the 2 parallel sides is going to be y2 and y3. Now this one, the sum of the 2 parallel sides will be y3 and y4. but it's still a half h because I spaced these uniformly. And then this one will be y4 and y5. Right, we have a common factor of a half h, obviously, because they were all h across. And then look, I've got y1 and y2, because this one here is the right-hand side of trapezia 1 and the left-hand side of trapezia 2, so it features there and there. So the first one only features once because it's the left-hand side of trapezia 1 and that's it. Then this one is a right-hand side and a left-hand side. This is a right and a left, this is a right and a left, so we get 2 of all of those. But then that, y5, is only the right-hand side, so there's only one of those. And there you have it. There, h, that's the difference between the x's. X ordinates. That's the far left y value. This is the far right y value, this height here. And then these are the other ones.